Hey guys, we're going to do a video here on piecewise functions, which are really interesting things. So first question is what is a piecewise function? If you've never heard of it before, here's some examples. Let me show you a couple of graphs. These are piecewise functions. You can kind of check them out. What they are is they're graphs and they're functions, but they're graphs that are made up of multiple types of functions. These two examples, you can see it looks like it's a regular line, but then it turns and then it turns again. And here we have a line and a line. And what's going on here is we've pieced together different lines with different equations to make the graph. So it's pieces of lines that have been put together, hence the name piecewise functions. And what we will really want to be able to do is we want to kind of think about some questions here, and then we want to be able to graph these ourselves. And so the first question is, are these truly functions? Are they really functions? And what parent graph do they come from? And I kind of already answered this just talking out loud here for a few minutes, but yes, they're totally functions, and I know this because when I draw a vertical line, no matter where I choose to draw that vertical line, it only crosses the graph in one location. It passes what we call the vertical line test. This might be a review for you. The vertical line test is proof that this thing is a function. And does it pass? Yes, it does. Vertical line test says if it touches one place only and no more than one place, it is a function. So we would say this one definitely passes. It is a function. This other one is the same story. No matter where I draw my vertical line, it only crosses the graph in one location. So again, it is a pass on the vertical line test, and yes, it's a function. Now, the parent graph is what family of graphs does this come from? And in algebra, we learn about different families of graphs, and one of the big ones is linear. Linear stands for lines, and these come from the linear parent graph. These are made up of various lines. So yes, these are linear graphs in kind of a way. They're linear, piecewise graphs. And so what we got to work on is how do we make these and how does it work? So we're going to try some of that. That's the next thing we're going to do. And for your video, we're going to write this down as example 1. And here is example 1. What we're going to do is we're going to have a function. We're going to say let y equal, but instead of just doing a regular y equals mx plus b, I'm going to make it a little more complicated. And I'm going to draw this thing. It's called a brace. Looks like this. And in this brace, I'm going to put two equations for two different lines. The first line is going to be negative 3x minus 2. And the next line is going to be 2x plus 1. So I'm letting y equal two different lines, negative 3x minus 2 and 2x plus 1. But I'm going to add on some stipulations. I'm going to add on some rules. I'm going to say if x is less than negative 2, and I'm going to say if x is greater than or equal to negative 2. And now, in front of me, I have a piecewise function. This graph is going to be two lines pieced together. So now we got to figure out how do we actually do that. So here's the first step. Draw an xy axis and definitely be using your ruler and make sure you're making straight lines and making this graph very neat and organized. So I'm going to draw my y-axis here. Hopefully pretty neat and organized. I'm going to draw my x-axis. I'm going to label it X and Y and be really good about my labels. And what I do once I get my graph kind of set up, usually I go in here and kind of start doing all my scale numbers. That way I'm very detailed. The good graphs all have scale numbers. We know that's important. But here's the thing I'm really going to focus on, is where do these two lines piece together? And the focus for that comes from this part here. These are directions to the person reading these equations. The directions are saying that at x equals negative 2, these two lines are handing off to each other, so to speak. And we call that kind of like our boundary almost. Or yeah, it's kind of like a boundary. So we're going to go to negative 2 here on the x-axis because it's x is less than and x is greater than negative 2. And to help me kind of remember what I'm doing so I don't forget what I'm doing, basically what I'm going to do is I'm going to go draw a dotted line right here. So here is my dotted line. It'll look like that. And then I've now divided my graph. I have a left side, here's my left, and a right side. each side's going to have a different equation, specifically coming from these two equations, this rule. The left side is all the values on the x-axis that are less than -2. So when I say left, I'm talking about x is less than -2. And when I say right, I'm talking about all the greater than values. This is x is greater than -2 on the right side. So I've now split the graph up into a less than side and a greater than side. And so now, here comes the work. Now I have to graph these two lines on their right sides, the left and right sides. So I'm going to be sure to do this in pencil, and I'm going to be sure to use an eraser because I'm going to be doing some erasing when I'm all done. I'm going to grab a pencil here. Make sure I have a pencil. Awesome. All right, so let's grab a pencil and let's start with the first one, -3x minus 2. Now let's just graph it like normal. This is mx plus b. It starts at -2, so let's go to -2 on my graph, which is right here. Let's make that the starting point. I'll put a little dot there in pencil. And it has a -3 slope, meaning it's going down 3. Down 3, 1, 2, 3, over 1. Down 3, 1, 2, 3, over 1. I'm also going to reverse that process, and I'm going to go up 3. 1, 2, 3, back 1. 1, 2, 3, back 1. Lands on the dotted line. 1, 2, 3, back 1. And you can really see once you kind of use your pencil that the line is basically going like this with your ruler. There's my line. But when I go to actually graph it, even though I'm like in my mind thinking that this is my line, I'm going to lightly graph it with my pencil. I'm not going to graph it too darkly yet. So here's a light sketch of my line. Very light. It's probably hard to see on the screen. The thing is -3x minus 2 is if x is less than -2. So now you have to look at your line and say, okay, here's my entire line. It's my pencil. But where is it less than -2? Well, only over here on the left side, which means I have some erasing to do. All of this side right here is on the right where it's greater than -2. It's supposed to be on the less than, so I'm going to erase this part of my line. I used it to graph, but now I don't need it. I'm actually going to only have a line going from here up, only on the less than side. All right, that's one piece of my graph. What I've just done is I've just graphed this equation. I'm going to check it off, and I've done it on the less than side. Check. Now let's do this one, 2x plus 1. 2x plus 1 starts at +1. It starts here at 1. So again, I'm going to use a pencil so I can do some erasing. So I'll start at 1. And it has a 2x, an mx of 2, so the slope is 2. So I'm going up 2 over 1, up 2 over 1, up 2 over 1. Or think of it in reverse, down 2, back 1, down 2, back 1, down 2, back 1. And again, we get this nice looking line, which with my ruler I can connect, but when I connect it, it's going to be very lightly done in pencil again. Very lightly done. Not even worrying about my arrows on the line yet. There's my entire line, but look at the directions. The directions said for x is greater than or equal to -2. On the greater than side is the right side, which means when I go to connect my line, I can only connect it from here up. Only on the right side, on the greater than side. That means I have to erase this side. I'll do some more erasing here. Hopefully this will kind of come off the screen good. Which means we've basically just created our two pieces, our two lines in a piecewise graph. And we're almost done. In fact, I'm going to check off that I just did this line and we did it on the greater than side. The only thing I haven't paid attention to and dealt with yet is the one last final little detail, but it's an important detail. And it's this thing right here, the equal sign. The equal sign was with the x is greater than line. It's with the 2x plus 1. If there's an equal sign, then right here on our dotted line, we have to make a solid point. But we have to make a solid point with the equal sign equation, the 2x plus 1. Well, that's this one, isn't it? This is the 2x plus 1. In fact, I'm going to write right next to it, y equals 2x plus 1. That's that line. So that line has the equal sign, so that line gets a nice solid point here, right there at the dotted line. It's going to be very solid. But the other equation, negative 3x minus 2, does not have an equal sign. So right here at that solid point, what I'm going to do is kind of erase my pencil marking as best I can, and I'm going to make that an empty hole because there is no equal sign there. There's my empty hole because there's no equal sign up here. And then I have that side of the graph. And now I am all done. I have an official piecewise graph all put together, and it looks a little messy with the erasing, but that's pretty much it. That's how you do a piecewise graph. So let's try another one because that was kind of a basic one. Let's try a second one. So we're going to do an example 2. All right, example 2, same idea. We're going to have a function. We're going to say this time let's say let f of x equal. But it's going to be a piecewise graph, so I'm going to make this brace that looks like this. And I'm going to say let f of x equal x. And I'm going to say let f of x equal negative 2x plus 9. So I've now created 2 equations for f of x. But I'm going to make up some rules. I'm going to say it equals x if x is less than or equal to 3. And it equals negative 2x plus 9 if x is greater than 3. And so now those are the rules. I'm ready to graph. So let's go ahead and set up our xy axis and go through this process again. So I'm going to draw a nice xy axis. There we go. Always using my ruler, trying to be neat and organized. I always want a nice, neat graph. I don't want to be sloppy. There we go. And we know that we got to set up a scale and put some numbers on here, but we also know that we really need to pay attention to the rules of the equation. The boundary is what I like to call it. And in this problem, our boundary is right here. This is what you have to pay attention to. X is less than, x is greater than 3. 3 is the boundary for x. So we go to our x-axis, and we go to 1, 2, 3. Here's 3. And we draw a dotted line so we won't forget that this is the area we need to pay attention to. So here's 3. I'm going to draw a dotted line, dividing my graph in half, creating a left side and a right side. Here's my left. Here's my right. Awesome. Now, for this left and right side, I'm going to also include something else. This is the number 3, and this is the left side, the less than values. So this is the x is less than 3 side. And this is the right side, so this is the x is greater than 3 side, which makes sense. So now using my pencil, I'm going to do all my graphing. That way I can do some erasing afterwards. So let's go up and look at our equations here. Maybe I'll zoom out if I can a little bit so you can see these. So the first equation is f of x equals x. That's a really easy equation to graph. It's x plus 0 if you really think about it. So it's a graph starting at 0, starting at the center of our origin. And x has a slope of 1 that we don't even see in this problem. So it's just going up 1 over 1, 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 creating this line, which I can see with my ruler that is a nice perfectly straight line. I'll even connect it really lightly with my pencil. But now I got to focus on the directions and see what's going on here. So f of x equals x is on the x is less than 3 side. So look at the graph. X is less than 3 on the left. So this one right here, this is the left side graph that we just did, which means on the left I can connect it from here out. It's connecting. But on the right, I gotta basically go in and delete it. I cannot have the right side, so I'm gonna erase the right side. That's the rules of the piecewise function here. So get rid of the right. Then I'm gonna flip and do the next one. I'm gonna do negative 2x plus 9. Think about that. It starts at a plus 9, so I'm gonna have to count up to 1, 2, 3, 4, 5, 6, 7, 8, 9 to get that graph started. And I'm gonna use my pencil again. And this one has a minus 2x rule, so it's going down 2 over 1, down 2 over 1, down 2 over 1. That actually touches there. down 2 over 1, down 2 over 1. And you can see that if I take my ruler, it does a nice line. It starts up here at 9. And I'll lightly sketch it through all these points that I just made. There it is. It'll come into focus hopefully on your screen. And again, paying attention to the rules, this one is supposed to be on the greater than 3 side. It's supposed to be on the right side. So here's the right side of the line. It's over here, which means this direction is totally okay to connect, but the left side was not okay for me to do. So thankfully, again, I did it in pencil, so I can do a little bit of erasing here. So I'm going to do more erasing. Thank goodness for erasers. And then I'm almost totally done here. I just have one last question, and that is, where's the equal sign? Because I have to figure out the solid versus the empty hole. And the equal sign is here. It's on the left-sided one. X is less than or equal to 3. So here's the left side, which gets a solid point. The right side gets an empty hole, but ironically, the left and the right in this graph overlapped. Look, there's overlap. So actually, there will be no empty hole because of the overlap. The left side's equal, the right side's not, but it fills in the hole no matter what. The overlap keeps it a solid hole. So it's definitely going to be a solid point. This is a different case than the last example. Remember, look back at the last example. The last example, one was solid, one was empty. There was no overlap. So it just depends on the graph. There are lots of different piecewise graphs. They get way more complicated than this, but this is kind of giving you an introduction to how they work. So to kind of quickly summarize, piecewise graphs are when you take different graphs and put them together with boundary rules. You have to put a dotted line on your boundary, and you have to figure out your left and your right side and focus on correctly graphing those together. Okay, so that's something new. I hope that helps. I hope if you're watching this as a review video that helps also. And we will, of course, work on this in class. All right, bye guys.